Hello! Olá, pessoal. Boa tarde a todos. Sou o Fábio, mais conhecido como Trentas. Estou aqui hoje com ilustres presenças aqui que vão falar conosco sobre performance tuning, que é um tema sempre foi muito quente e acho que agora o momento que a gente está vivendo vai ser ainda cada vez mais. Eu gostaria de primeiro agradecer o pessoal das comunidades que ajudou a gente a fazer um barulho para poder trazer todos aqui. Eu gostaria, por favor, se vocês puderem se apresentar. Pode começar, Jean? Não estamos te ouvindo.
Clássico. Tudo bom? Prazer, pessoal. Sou o Jean Lucas, lá da Confraria dos CTOs. Prazer ter todos aqui. Espero que esteja dando para ouvir bem. Passei o link aí também de novo para a galera. Então, sejam bem-vindos. Vai ser bem interessante essa palestra. E estou aqui para acompanhar junto com vocês.
Legal. Gui, por favor.
Fala, galera. Aqui é o Guilherme, vulgo Gui Santos da comunidade, plataforma. Eu tinha me afastado um tempo por questões pessoais, mas agora eu estou de volta a todo vapor. Fico muito feliz e a gente está se reunindo de novo. Espero que a gente continue se reunindo no final do ano que vem. Então, a gente vem discutindo várias palestras e papos para a gente ter com vocês. A gente liberou um site novo também. Por enquanto tem quase nada lá, mas até o final do ano vai ter um monte de surpresa para vocês, beleza? Bom evento para todo mundo e bora falar sobre performance.
Legal. Bom, agora, como nós temos pessoas que não falam português aqui no palco e também pessoas assistindo a gente vai mudar para inglês e vamos seguir de agora em diante. Hello, everyone. My name is Fabio, and I'm sorry for the Portuguese Brazilian beginning, but it was important for us because it's a Brazilian webinar that we are promoting. The idea today is to talk about performance tuning with great friends over here, Martin and Stefano, and I'll be the MC. Well, I think we should start, right? Let me put all three of us in stage. And yeah, well, I think we can start. I have some questions here that we can start talking. The idea is to have a round table, and I hope you can enjoy a lot. And I also have a slide view here for Q&A. I will keep posting, and I will keep posting, so you can do any question there, and then you can upvote the best questions so we can prioritize after the webinar. We will answer all of them. Okay? Well, we can start. First, I'd like to bring some foundation concepts. The question goes to both of you, of course, but the idea is, what are the key metrics you prioritize when accessing systems performance?
Right, Martin, you wanna start?
I can, take a shot. Cool, perfect. First thing, thanks for inviting me. And I'll probably, as a very political person, it all depends, and depends on what you call performance too. Going back, I like to put a few different hats in performance. It's not just what people call response time, but also scalability, throughput, efficiency as a whole, your resiliency and availability. All those things kind of go together, and usually have trade-off between those things. So it depends on what you're trying to, I guess, optimize for. So, hey, we're talking about performance, meaning I have one user, and that one user is seeing slowness. That's one thing. Hey, I have a lot of users, then they start having problems or the system falls over. It's a different story. Or, hey, it's fast, it's good, but it's super expensive. Different problem. Usually, at least talking response time things, I'm not a big fan of looking at single metrics to start with. Everyone who kind of knows a bit of statistics know that, all those aggregations kind of lie to us. So if possible, I'll always prefer to look at some sort of distribution, or at least kind of some multiple deciles of things. I like to look into the different layers too. I think that's important. Say with talking end user, I don't want to simply check response times for the user, but I also want to check server side to see if something is internal, external. So all those guys. End of the day, queuing theory, service completion time. It all goes back to queuing. Throughput, same thing. We really care about both the incoming and outgoing, right? So arrival rate, completion rate. And at the same time, if you probably have queues in the middle, you probably want to keep checking queue sizes and this sort of thing, deny rates, and so on and so forth. Hey, we're talking efficiency. There's one thing probably Stefano can talk more about it than I do. So non-utilized resources. Are we actually paying for stuff that we're not really using? And that could be at a really high rate. I have an instance and I'm just not using it fully. I was not using it at all. Or lower level things if you have access to that. Like, for example, IPC, the instructions per cycle on your CPU. Maybe your application has a lot of contention and you're just not using the CPU to the full extent. So that's kind of important too. And at the high level, end of the day, cost to serve tends to be important for the business and kind of important to me and my organization. And you need to normalize it with something. And it kind of depends on the business itself. You could do a cost per user for the whole infrastructure. You could do a cost per transaction, or you can go a bit lower, like I do in my platforms, which is vCPU per request and things like that. If it's an application that is CPU bound, I would say. So it kind of depends, like every good answer. But it really depends on what you're trying to optimize for and what's the main goal. And that changes from problem to problem, business to business. I would say, like, hey, for Netflix, response time was really important to us because response time directly related to user perception, retention, acquisition. Other companies, hey, our perception is pretty good already. We don't have to worry. But we need to improve cost to serve. I need to reduce my infrastructure footprint. So it kind of depends on the business goal and what you're trying to optimize for. Stefano?
Yeah, right. So you basically said it all. So no, that's great. And by the way, I like the fact that you mentioned queuing networks, because actually I've been doing capacity planning for I don't know, last 15 years, and I think it's also important to kind of devise a good methodology for performance engineers. So not jump straight to, I don't know, let's open some tool and understand what metrics does it provide, but having an understanding, of course, starting from the objective of basically a methodology. So what in capacity planning, it's interesting because actually you try to kind of break down, you have a whole system, maybe, I don't know, a storage array, maybe a set of microservices on Kubernetes, it may be just even a JVM or just even a CPU, and try to understand what are the building blocks of your system. And you try to model each building block with basically the queue networks is a kind of mathematical model that tells you basically that each resource is doing its own work and you have queues in front of it, because of course there may be more work that needs to be processed. And at the end of the day, your application, your system, so what you're analyzing is kind of a set of interconnected networks, queues. And that's very powerful because, again, if you're going to study, I don't know, a Kubernetes microservice, you are going to focus, I don't know, on the JVM, perhaps on the container level metrics. So you have several resources, several layers, but you can also apply the same methodology to analyze a more complete application. So perhaps you have a set of microservices that are interacting, the database, the API gateway, and you can apply, it's important for me to apply this kind of, as a suggestion also for performance engineering, when you need to identify, for example, where is the bottleneck, having this kind of methodology in mind and try to understand what are the different components and break down the system. And then you can measure each single component, like, for example, Martin was saying, usual metrics. Methodology is the more practical. I would recommend, for example, use method, which, by the way, was invented by Martin, former colleague Brendan Gregg. So basically utilization, error, and saturation and error. So for each basically building block, for each resource, you measure how much it is being used, how much work is still being to be processed, which is kind of a more infrastructure way to measure things. Then you also have the kind of more user-facing metrics like red or golden signals, popularized also by the Google SRE book, like response time, error rate, throughput, and those are more kind of user-facing. And of course, nowadays we talk a lot more about also the financial metrics, the cost. So it's kind of a trade-off, like Martin said. So that's my recommendation, basically.
Nice. Super cool. And talking about the common pitfalls now, we see that a lot of teams they do common mistakes when they try to optimize performance. And I'd like to have a discussion here to understand what are the common mistakes that they do. And I'll start. I think first mistake is that teams usually just look at performance when we have an issue. And in my opinion, we need to look at performance every day. It's like nail cutting, right? What do you guys think?
Yeah. Go ahead, Stefano, since I started.
Oh, I guess the list is long, so
it's definitely a long list. I mean, definitely, but at the same time, frequently I see the opposite, which I call like premature optimization. But again, it depends on the company and how motivated engineers are. It's really when you try to optimize something that might not need optimization, or there's no business gain from that specifically, or hey, you want to start with the complicated stuff first. You want to go directly to your algos, and before you actually look for the more low-hanging fruits. There's a funny story, well, sort of a funny story. I don't know where it originated still, like after many years, but one day my colleague in Netflix, Scott Emmons, he brought the performance mantras. And that ended up in Brendan's book later, and so on and so forth. And I still don't know who actually. It wasn't Scott. It was someone who mentioned to him, and I'm still trying to figure out who is the original author of it. But it does make a lot of sense to me in the order you do things. And here's the good things in this specific order. Like first thing, if you don't have to do something, don't do it. Like, hey, you actually calling a dependency and you don't really use the result of it, there's no point of actually doing it in the first place. So find things that just you don't need to do and don't do it. And second, hey, I have to do it, but I have the option of not doing it again. Caching. Can I cache something? Can I just don't do it again? That would be great. Hey, it's not always that I can, avoid doing it again, but maybe I could do it less. Maybe instead of kind of calling a service all the time, I might refresh async and keep results for a while. It's one option. Can't really do it less, but hey, maybe I don't need to do it right now while I'm blocking the user. Do it later. Or do it while they're not looking. So instead, again, blocking the user, don't do it while they're looking. Last, hey, no way of avoiding that. Can I actually at least parallelize that? Instead of doing a synchronous way, can I create multiple threads, multiple processes, and actually process that in parallel? That would be great. And last, you actually look at your algos and ways to improve that. So start with low-hanging fruits, and then go to the more complicated stuff in the first place. It's the probability that you have more gains from the low-hanging fruits than the complicated stuff.
Totally.
Great. And also, perhaps what I may add is that we often see people not starting with. Typically, it's for example, if application performance issue, they start from looking at the infrastructure. So it's they tend to focus oftentimes what I see on the kind of the wrong places, or at least they don't measure the full pieces in basically, for example, in the response time of, I don't know, an API call, they just go straight to using the usual tools and look at CPU usage, etc., which is fine, which is because it's easy, but oftentimes that may kind of trick you into thinking that you will, by fixing a bottleneck in tuning some, for example, the JVM, this will automatically lead to faster user response time. And sometimes it's kind of the opposite, because focusing on very specific detailed metrics may not always correlate with what you are trying to achieve, lower cost or your response time. For example, I published a blog post on tuning the JVM, which is kind of the single most viewed blog post on the Akamas website, which basically tells the story that everybody's tuning the JVM looking at the garbage collection time, which is basically the amount of time the garbage collection stops the application. So it is not good, right? So that's the enemy. So let's try to tune the JVM to kind of reduce the garbage collection poses as much as possible. But at the end of the day, if you do that, you might impact the response time even negatively. So if you have, for example, a configuration that reduces the garbage collection, they may start slowing down the application due to the fact that the JVM may use more CPUs to do that, and that will in turn compete with your application for resources. So you may slowing down the application due to the fact that you are making the garbage collection or the JVMs faster. So focusing on the right metrics is important, and that's one of the issues that is there is that also the observability practice is not always great. So we say that if you do this exercise of mapping the components of what you need to measure, you often find that some important pieces in the stack are totally not even measured. So even by leading tools that we have, so that's another kind of a problem.
Yeah.
Yeah, and I have an interesting example on that too. On the going straight to the infrastructure, memory leak is something fairly common. Providers tend to work on it frequently, and especially with the cloud. I'm pre-cloud. I guess you guys are pre-cloud too. One really great thing you can do these days is I don't have to worry about memory leak. I can just kill the instance. So there's like sometimes easier fixes to a few problems than probably finding the optimal solution there.
Again, I remember some customers that were using that. Yeah. I remember some people that was doing that even prior to the cloud. So interesting.
And this is a good point, because I think with the rise of the cloud native environments with containers and etc., this impacted some strategies of performance tuning. I remember when I was a young sysadmin in the late 90s, compiling kernels and running a lot of tools by myself on production environments. I think it was actually easier than it is today to when you are trying to figure out what's going on with a performance of an application. Yeah, it's been a while, Guy. So what do you guys think? How these the cloud native environments impact the strategies of performance analysis?
Yeah, well, my end, I think theory remains exactly the same. Still a queuing system, just a lot more complex. So end of the day, what needs to change for me was really the tools and techniques I had to use to do the same job. Like a few things that I had available before, I don't have anymore. Like cloud is a great example. Unless you're using a bare metal instance, you probably don't have access to a lot of the hardware information, what's going on in the back. So how can I I would say go around it, but how can I supplement that with other information to make the right decisions? The complexity of the systems and how you observe them, the amount of data you need to capture to understand what's going on with the system is a lot greater. So you need new paradigms on how to collect that data, on how to visualize it, and how to make decisions. Like in the past, it was fine. You had a system; it was easy to do system design. You could actually get a piece of paper and design what's going in a system. Today, I mean, with thousands of changes every day, thousands of microservices, it's a more alive organism, I guess. So you need to adapt your tooling to understand that. What's the traffic flow? Who is calling who? And what are the different patterns from requests? It's just different tooling you need to use. But at the same time, you have a few more options too. Like, for example, hardware in the past was not, ephemeris. Now you have that option. Like I mentioned with the kill the VM instead of fixing the memory leak. You have a few extra options, but there's a lot of new constraints, I guess, especially on the complexity and amount of data.
It's easier to live with a memory leak comparing to the past, right? But you don't fix the problem.
Yeah. And the cloud is not as elastic as people think. Amazon also runs out of instances. It happens.
Mm-hmm.
No, it's great because I think that is something people not, of course, once you realize once you kind of start working with those much more distributed systems. So I would say so. If you look at each single microservice, at the end of the day, the stack is kind of similar to the monolith. So it's you have the container, so you don't have perhaps anymore the OS, the operating system to analyze, but you have kind of similar metrics for the container. Then you have your runtime, like the JVM or Golang runtime, .NET, Node.js, that still need to be tuned properly. That is something that we see a lot of people miss. They simply just think that just looking at the container is enough, but in reality, it's kind of the same stack. So we see a lot of issues, like, for example, you have, I don't know, a pod with 4 gig of RAM, memory limit in Kubernetes. The JVM is configured with 7 gig of RAM. So completely something that is kind of incorrect and leading to out-of-memory errors and reliability issues at the application level. Simply, people seem to forget that within the container, you still have the application. So you still have all the layers, the application server itself, with tunable options, etc. But of course, you have much more moving piece with respect to before. So that's really becoming more complex. Also, platform like Kubernetes is great because it allows you to kind of standardize what is the platform. So even the auto-scaling and self-healing are great capabilities. Now you don't have to think anymore how to do that with, I don't know, AWS load balancer or Azure, etc. You just have one platform that it's always the same, which is awesome. But still, again, it's not just a simple flag like enable HPA, enable auto-scaling that, and Kubernetes will do everything for you. You still need to properly set it up, configure the probes. So the movement to cloud native is great in terms of kind of the vision, the benefits that you can achieve, but it's not an easy journey, I would say. And we work with many customers. We find that they are not basically understanding how the resource management in Kubernetes works, because it's kind of different with respect to what you had before. So that's kind of the problem. And also in terms of strategy to analyze and kind of take care of performance, for example, you have also some advantages. For example, the microservices are kind of smaller, so they do kind of one thing, well-defined thing, which is useful, for example, to do performance testing. If you have an API that does, I don't know, one or two, a very limited set of capabilities, it's easy to set up continuous performance testing in the pipeline. So we see that is some customer of ours implement those kind of strategies. It's not still very widely adopted, but it become easier with respect to, for example, doing performance testing of a monolith. So it's a smaller piece. You have less cognitive load also in managing it in production. But the complexity then translates to understanding the whole system. So it's more dynamic. Like Martin said. So you need to better understand the interaction. So instead of, I don't know, deeply profiling one microservice, is kind of the focus is also for observability kind of shifted to understanding how the whole system perform, what are the bottlenecks in the system, and those kind of analysis, I would say.
Yeah, and also before the cloud native era, we needed to feed our applications in the limited number of servers that you used to have in the data center. So in my opinion, we needed to do a lot of performance tuning initiatives at that time that was much more needed than today, that with the elasticity of the cloud, it helped us a lot. But the other hand, we don't know how much we are going to pay because of that. So that's why, in my opinion, performance tuning and FinOps initiatives are very connected.
Yeah, and it kind of brings me back to many years ago. I was at a conference with Goranka. She was like, I think, head of the capacity engineering team, capacity team at back then with Meta, yeah. And they had a kind of interesting policy there, or you still have a data center is elastic, yes, you can allocate, but you had an allocated, your team had an allocated capacity, and if you have a regression or something it's out of ordinary, they would not give you new capacity unless you go and take a few steps and optimize things first. So it's an interesting policy I always found.
Cool stuff.
It brings back us to the old days where you actually have to order hardware and wait 6 months for it to come.
Yeah.
That's attention we see a lot also. Like you mentioned FinOps, because we see that there's great interest in those, of course, cost saving. So on one side, you get to use all the cloud capacity that you want. So many teams are more autonomous today. So even a cluster autoscaling feature of Kubernetes, you simply don't have any more kind of fixed capacity that you need to kind of stay within. But of course, the downside of that is very, very easy to overspend, especially on Kubernetes, where you have many more moving parts. It's very easy to kind of add a buffer of capacity to each single microservice, and at the end of the day, you get a cluster that is huge and it's full from a kind of capacity perspective. But if you look at the actual utilization of CPU memory, there may be even 4%. So it's something that you need to really look into. Otherwise, you will waste a lot of money. And also, by the way, at the same time, you may still have reliability issues, which is kind of counterintuitive. So despite that you throw a lot of resources at the problem, if pods are not configured correctly, for example, you may even end up in, I don't know, out-of-memory errors, etc., due to the dynamic nature of the traffic, new releases, etc. So it's kind of much more a moving target with respect to what we had before, I guess.
Great. And talking about cost, what's the best balance between performance and cost? How can organizations achieve an optimal balance, especially in cloud environments?
That's a tricky one.
Yeah.
It's tricky because it depends on your business. It's hard to measure the revenue impact of slowness. Let's say, I'll take an easy example, e-commerce site. You can easily, I would say easily, okay, but it's not terribly complicated. You measure the impact of slowness. If you get, some page that is slow, and then you optimize the other way around, you can see the abandon rate within that checkout process, for example, and then you can probably derive on how much does that cost. There's a few, I would say, industry metrics. Every 100 milliseconds cost X amount of retention, and so on and so forth. Not a big fan of the industry numbers. You can use it for some ballpark estimations, but usually I prefer to measure it myself. If you have a transactional business, it's a bit easier. Take for example Netflix, which is trickier. It's a subscription. For how long things need to be bad for the user to decide to cancel his plan. And that varies. Like there's a few cultures that are fine with some level of bad experience. There are other cultures, like Germans, that just don't take that really well and just cancel right away. And then what are the different dimensions that impact that? So measuring that is really tricky. I probably spent over a year creating that model. But I know exactly, hey, 100 millions of app startup time on iOS costs us that. I mean, it's a model, it's an estimation for sure. But then with that, bringing that to numbers, you could balance the cost to serve a user and versus the other. So that's, I usually like to bring everything to numbers to be able to balance that correctly.
Mm-hmm. Yeah, and I could answer that. I think it also depends, but depends on the company that you are working. Because if the company is like chasing a break even, cost is very important. But the company is chasing growth, just for growth, well, doesn't matter what the cost is easier to focus the other side, right? Great. And what about tooling? I know that there are some questions already here for tooling, eBPF, etc. But what are the tools that you recommend to do analysis of systems performance?
I go this time. Okay. So basically, we at Akamas, basically we work with many companies. Basically, we tend to adapt to whatever the company is in place. So we work a lot, for example, with Dynatrace, which is one of the leading observability tools, Datadog, or even Grafana. So I guess what is important is to have visibility across the full stack, which is I guess the key thing. So being able to basically go end to end from the user transactions that are entering our kind of API gateway, etc., down to the application runtimes, the container, and down to the hardware. So the ability to cover the full stack is important. The ability also to have a clear view of the cost, like we mentioned. So in general, so that's I won't recommend any specific product, but to me, it's important that you have this ability, because sometimes we find tools that are not able, for example, to instrument the runtime, so to understand the response times of, I don't know, Python microservices. So sometimes it's not easy for some kind of technology stacks. For others, is more kind of an established approach, but the ability to kind of have a full view, because what that enables is, like you the previous question was, how to correctly balance cost and performance, drive the right optimization goals. Because sometimes we see people just go straight to the infrastructure piece, and I don't know, they may adopt a new cluster auto-scaling solution that do wonders at the, I don't know, infrastructure level, but what is happening to application performance? Am I slowing down some critical microservices? Am I don't know, causing some performance degradation for some kind of users or some kind of APIs? So that is important. So one of the biggest trend that is very excited about is the open telemetry kind of trend. So because another issue is, especially working with many tools, is that each tool today has its own metrics, its own semantics. They are all different. So perhaps you need this metric for a particular analysis, but you don't get it on the other vendor. So OpenTelemetry is great, because one of the things that I like the most is that you have this semantic convention across the full stack. So you know that an HTTP call response time has always the same name. You can find it across all vendors, and the ability also to have this neutral open source piece is really important.
Yeah, I think definitely the end-to-end is super important, and that's why I'm not a big fan, diehard, of any tool, because I don't think any tool today available in the market actually gives you full end-to-end visibility into all different sorts of stacks. But I'll also add that it depends a bit on where you are in your performance optimization maturity journey. For your early steps, there's a lot of stuff available. If I don't even have an average response time, that already helps. But that's like early in the beginning, baby steps. As you kind of get rid of the most basic problems, you'll start digging deeper and deeper and deeper. And especially on that deeper end, there's not a lot of, I would say, package tools available. You probably need to combine some of your own development, some open source stuff, to actually get all the information you need. Like, you have any decent, OS level profiling tool that does the job and does the symbol mapping for all sorts of languages really well, and all those things are kind of tricky to solve in a more generic way. So you probably need to get what's available, adapt, create your own as you dig deeper and deeper. I'll also point out one thing that I see missing, or at least I miss from a lot of tools. It's properly using the right visualizations for the right thing. If you never read Tooth, to actually get a bit of that. But hey, am I optimizing for slowness? Maybe like Chrome's flame chart, which is different from a flame graph, where it shows you the timeline view, works really well. Maybe I'm optimizing kind of for hardware consumption and some sort of optimization on that level. Flame charts might be better. Or I'm looking for perturbations. That's a different kind of visualization. So having that range of visualizations is also super important. It's something I see lacking in the tools, but I do understand why. I had a chat with like New Relic's chief architect a while ago, and we were discussing why doesn't have all those cool things, and most people just don't really know how to use it. And you just complicate the product. You'll be a worse product for most users, and you need new global optimization for that. So it's always that trade-off. So I don't believe at one point we'll have a perfect tool to do everything, and you'll probably need to mix and match depending on where you are.
Yeah, I think one of the things it's great is the Prometheus ecosystem has a lot of exporters. So, for example, you can bring in data from pretty much all the layers in the stack, even energy data, cost data, JVM level, runtime level data, and even eBPF. Fabio, you mentioned eBPF, so there's a great exporter there. So you pretty much can do whatever you want. So basically, of course, this requires more skills. So coming back to what Martin said, so if you're at the beginning of your journey, there are lots of exporters that are already available, so with little effort, but at least you have the ability to kind of go deeper, and that's something that also might converge in the open telemetry ecosystem. That would be even better.
Yeah, and also if anyone here is like starting working with performance, I strongly suggest that you look for profilers. I think profilers are a tool that are available. We have open source options. All the enterprise APMs, they already have a module to do profiling, even in production environment, because today they are more lightweight than it was before in the past. So I strongly believe that this is a good start to understand what's under the hood. And I'll do just one more question here, and then we can switch to the questions from the people who are watching us. Okay. My question here is regarding application, code, or infrastructure. What comes first? Which is best to achieve a better performance? Tricky question, I know.
Yeah. I think go first, and then.
Oh,
I think you're mute, Martin.
I can start with that, and I think Stefano has a lot to complement. At least from my point of view, there's a logical order in the tuning process. Usually I want to start with the highest level of abstraction and then, get deeper and deeper. Why? Generally, when you change something up the stack, it will change the workload and how the bottom layers behave. So the tuning you do maybe in your application stack or OS will not be valid anymore if you go the other way around. Having said that, there are always exceptions to that sort of thing. For example, also you start with that because the application has more low-hanging fruits usually. But on the exceptions, you could apply certain optimizations to lower levels if they theoretically don't have negative impact in the layers above. So you have a low-hanging fruit, something fairly simple to apply, and in theory there's no impact to the application layer. Why not do it? And the one I usually apply the most is horizontal optimization. Its application is really one-on-one, right? Each application has its own behavior, and you have to tune one application at a time. But when you go to the lower layers and you have a fairly large environment and everyone shares the same abstraction layers, you could get a bigger bang for the buck by optimizing the lower layers. Hey, I could apply an optimization to Tomcat, and that everyone uses the same Tomcat with the same configuration. So cool. JVM, got an example too. Infrastructure and I don't know, your auto scaling rules, whatever. And those cases tend to be fairly good too, because you get a large bang for the buck quickly. So that's fair game too, I guess, on my thinking.
No, I agree, because actually, of course, you can do it's kind of complementary approach, right? So you can work at fixing the application, or I don't know, a bad query on the database, and you can work fixing, for example, configuration of the auto scaling or your pods. The way we kind of like to approach it usually at Akamas is fixing configurations first, because first, it's much easier because, for example, profiling code, you need to have some skills from the development team. You need to prioritize, put it into the sprint. But typically, people is more focused on kind of shipping new features. So you need to have a kind of a certain level of sponsorship and also maturity to do that. On the other side, configuration are kind of, on the surface, they are easier because they are just values. So I'm using 2 CPUs that just use, 0.5, and let's just release it. Of course, the complexity comes in, of course, finding the right configuration for all the microservices, etc. But that's something that kind of can be solved with some automation. So it's something that we do at Akamas with automation and AI, which may help SREs, etc., tackle this problem without actually impacting the development team. Let's say that much.
Yeah, I agree. Well, let's switch to some questions from the audience. The most voted here is from Gustavo. He's asking, Martin, some engineers at Google and Meta say that eBPF is the future. What's your opinion?
I worked a bit on that, I'd say. It depends on what you call the future. If not everyone knows the details of eBPF, it's nothing more than a VM that runs in kernel. You can run code there. It's nothing new. It's been there for decades now. Well, different versions of eBPF, but you guys get the deal. But it was used mostly for networking tools in the past. What it does and where I think it helps a lot is there were things we couldn't do in the past because they were too expensive. There's too much overhead to profile something, too much overhead to do certain things. So it was not viable to get some information. And since running things in kernel is more efficient, now we can do that. You can profile code directly from the kernel. You can do stack aggregations there. You can do a lot of things there and not go to user space. So enables us to do that. So I do think, yeah, there's a lot of new open doors, but at the same time, there are a lot of problems just don't require that. There were never a problem to that require that sort of efficiency. So yes, I think it's important to continue developing there. It is more efficient, less overhead. You can do more things, but at the same time, I don't think it's a silver bullet to solve all the problems. I think important tooling, invest in that, definitely, but not the super bullet that will solve all the problems.
Yeah.
Cool.
And also, if I may add, the other thing where it helps is also kind of instrument metrics that you couldn't have before because the tools were limited. So you had the ability to go everywhere and kind of track everything, but which is another kind of value. So the fact that it is standardized, so it can do much more things automatically. So also the out-of-the-box instrumentation, etc. So if once that becomes kind of pervasive, it will be a great value. But as you said, then you have more metrics to kind of understand and understand what to do, properly visualize, optimize them. So it's great as an enabling system. Then you, of course, need to make proper use of the basically the information that it provides.
All right, another question from Ricardo. Once performance tests are written, how do you assert the system performance doesn't degrade as new releases are released? Schedule load tests?
Yeah, but I know you did some cool stuff at Netflix, so
yeah. So I might have controversial opinions on that. It's kind of out of focus. 1 second. There you go. So the thing is, it depends on your development process, but also your release process. In my case, these days with large complex systems that deploy really frequently, traditional perf testing I don't think is feasible anymore. It was feasible in the past when you had waterfall models, when you had that phase to do some sort of validation, usually with within the QA time space, and then you had to figure out regression over time. It's just not how we develop anymore. At least not me, not my team for quite a while. So I try to focus perf testing, which is synthetically generate some sort of load, to more the experimentation phase, where I building something new. I have no idea how it behaves. I need to have some sort of feeling of how that behaves, but completely disassociate that from validation. It works at that scale because there's just too many variables, too many dimensions to actually reproduce production, to be able to say, yes, just because I ran this workload, it will run in production. So I try to stay away from that and just go to the experimentation. How do I guarantee that there's no regression? Monitor production. Try to do those things in production. There are techniques where you could actually validate failure scenarios, scale scenarios with user load. Some of you might have heard chaos engineering, failure scenarios in production in a controlled way. Great technique, hard to implement. Second, like for example, squeeze tests. Squeeze tests are great. It's something I'm trying to implement right now. Or how to actually generate a stress test in production with user load without having to rely on synthetic load. So there's a lot of new techniques that are not your traditional, I test, I put in production, and then I validate something. So it's just where you are in the whole development model. I see exactly the same thing for traditional QA too, right? Mm-hmm. There are other techniques these days.
And we work a lot also in this space. What we see, for example, it also depends, as you said, on the company, on also in the industry. So, for example, in the banking industry, so things are so critical that we see people don't want to touch production usually. So still today, so They rely on performance testing as a way to reduce the risk of shipping something broken in production, because they explicitly, for example, tell us, okay, you can optimize anything in production, so we do everything before in lower environments. That happens sometimes also in, for example, highly business critical e-commerce systems. Again, load test to try to reproduce the realistic pattern before releasing is so important, because you cannot really make anything slower with very high confidence. So I guess it depends on the strategy. But as you say, now we have much more kind of new ways to do that, which are sometimes more risky, but that's it's more realistic as well.
And the complexity of the system too. If you have a fairly small and simple system where you don't have that many variables, it's a lot easier to create a more realistic workload. While you have thousands of microservices and changes all the time and different code paths and different things that can happen with your infrastructure, is really hard to not just create, but maintain that synthetic workload to be realistic. It's just a lot of effort. That's why I gave up on that, because I would just spend my whole day trying to keep my load tests, from having some sort of regression not being realistic anymore. And it was just too much time that I spent doing that.
Well, folks, we just have 5 minutes left, so I will send again for the folks who doesn't know yet the Q&A place. If you want to upvote for the best questions, probably we cannot answer all those questions to respect the schedule here. But if you can upvote, probably we can do the question that you asked it for. So the next one is from Gustavo too. Martin, what is your opinion about the obstacles and challenges to integrating system performance with DevOps?
Cool. There's a lot of challenges, especially around the specialized knowledge, I would say. Imagine that your DevOps, your developers, assuming one that actually works and it's not just one guy that takes care of infrastructure. Developers care about their code and operating that. And the tricky part sometimes is that a lot of that performance tuning requires some specific knowledge, different tools. You need to understand, lower levels of abstraction to tool. And it's just more knowledge for developers. The bar is a bit higher, I would say. So the tricky part is really that. It's just more complex, more knowledge, which is tricky. The way, at least I managed to at least partially solve in the past, was really creating tooling that is easier for your regular feature engineer, help him evaluate performance in some way or another. A great most common example, back on Netflix, I would probably say in the early days, 3/4 of all help support requests were, my CPU regressed. What do I do? And that became really common. How can I solve that? I create a tool where engineer can go there, click a single button, get a profile, and get some sort of information pointing, hey, this is the method that regressed in that specific version, and then go look at it. So the real challenge is creating tools that abstract a lot of the complexities we have today with the tooling, which can be very complex, like using raw BPF, really tricky. How can we abstract that and allow engineers to take care of the easy common cases? But my belief is that if you're a large enough company, you still need a few folks who are specialized in that, just because it's unrealistic to expect your regular feature engineer to have that kind of knowledge. It's just remember your team topologist, specialized team, that sort of thing.
Yeah, I agree. It's what we see as well. So at Akamas, we are working on an AI-based platform that basically tries to provide a service that Martin was describing. So providing recommendation, analyzing all the observability data of all the microservices, crunching the numbers, and basically recommending a how to best configure the different microservices. So saving the time to do all the analysis, looking at the charts, the dashboards, and deciding what is that you need to change. So that's one of the area that definitely AI is kind of revolutionizing entire industries, also in the performance testing, tuning, SRE space. That's one of the area that is definitely helping and worth looking at.
All right. Well, last questions, and then we do the closing, okay? From an anonymous person. How has AI impacted the performance tuning processes? And what are some examples of AI-driven tools that can help optimize system performance?
That's yours, Stefano.
Yeah, that's nice. So, not sure who wrote this, but actually, no, actually, the AI, as I was saying, so it's everybody now is using AI. I guess things like ChatGPT, etc., are helping automating lots of tasks that were tedious to do manually. So in the performance engineering space or SRE space, I see that the AI has a lot of potential, which is still not realized. So at Akamas, what we do is we don't use generative AI. We use reinforcement learning, which is machine learning based optimization platform that basically helps finding the right configuration for the system. So things like, for example, I do ATU my JVM. So what the best garbage collector, the heap size, or my auto-scaling rules on Kubernetes, what are the best instance types on the cloud. So those are really hundreds and hundreds of choices that DevOps needs to, and SREs, performance engineers needs to make. So it's the optimization task is one hard task where it requires a lot of skills, and also it's a trial and error today. Still, if you have 20 years of experience doing that, there is no recipe that works for each single application. So each single application is different. So that's one area where AI can definitely help kind of reducing the time for to optimize and reach the benefits that we talked about before.
Great. Well, final words. Well, by my side, yeah. I just wanted to thank you guys. It was awesome. Great talk. I hope we can do more often, and super happy with the results. Thank you. Please, if you can say some final words.
Sure. On my end, again, thank you. I think for the invite. Friends know that I kind of love talking performance. I do that. It's not every day I can do that these days anymore. So I do enjoy the opportunity. It's something I'm definitely passionate about. So Spiel is, hey, want to chat? Feel free to add me on social networks, LinkedIn, and all that. Not a often poster, but always happy to chat. So reach out. Have an interesting problem. Let me know. Happy to help whenever I can. And also, finally, it's something that I was looking to do for a while, and finally got the right timing for the business to create my new perf engineering team at PicPay. That started a couple months ago, give or take, and we hired a great guy. We'll very likely be opening a few new positions later this year, next year. So if it's something that you're definitely passionate about, something you enjoy doing, feel free to reach out to, or keep an eye at least.
Tremendous opportunity.
All right. Also pretty much the same for me. So thanks a lot, Fabio, for setting this up, and the whole Brazilian platform engineering and CTO community. It was great. It's also a pleasure and honor to talk also with Martin, and all the wisdom that you shared about Netflix, etc. So it's great. So also for me, just reach out if you want to kind of continue the conversation on LinkedIn. It's what I use mostly today, and let's do it again sometime soon.
All right. Thank you.
Thank you very much.
Have a good day.
Bye-bye.
Thank you.
Bye.